Hey everyone, so I hope you're all back and refreshed and ready to go. We're going to be in chapter 14 today. Chapter 14 is actually my favorite chapter in this entire class. So we kind of start pulling together stuff in kind of an abstract way. So if you like abstract ideas, chapter 14 is for you. It's going to be like especially chalky talky today, so I'm going to do a lot of writing on the board and just kind of explaining what I'm writing. Because the best way to understand this material is just kind of like repetition. So I want to make sure all your notes are super kind of rich and good so you can go back and review them over and over again in your time. So the title of chapter 14 is Firms in Competitive Markets. And the first thing to think about is what is a competitive market? So the way we're going to think about this is in terms of a spectrum. So we've talked in this class about markets. Goods are exchanged in markets, but there's different types of markets. So on one end of the spectrum, you can have markets that are perfectly competitive. And then the opposite of this would be a market where there's a monopoly. So monopolies are firms that just kind of rule the entire market. So there's only one single firm in the market, that's a monopoly. The extreme opposite of that is a market where there's tons and tons of competition between lots of firms. And if you get to the very end of the spectrum where competition is as high as it can possibly be, we call that perfect competition. So what we're going to be thinking about today is firms that exist kind of in this region of the spectrum where there's competition. And specifically what we're going to think about today is firms that exist in markets that are perfectly competitive. So in these environments where it's not feasible to kind of make competition any more extreme. Okay, so what we're going to do is we're going to start by defining the features of perfectly competitive markets. Okay, so recall perfectly competitive markets are kind of at the end of the spectrum. So this is like going to be the extreme, and we want to think about what characterizes the extreme in terms of perfect competition. So the first defining feature is that there's going to be, I'm going to put this in quotes, many buyers and sellers. So on the surface, this is kind of intuitive because if we're going to have, first of all, lots of firms competing, then we need to have many sellers. But there's also going to be many buyers. And if we're thinking about the extreme, then it's kind of like we're going to take the number of people in these markets and just kind of push it out towards infinity. So the idea is if we're at the very, very end of the spectrum where we have perfect competition, then there's basically going to be like kind of an infinite number of buyers and sellers, or we're going to try to approach infinity. And if that's true, if there's kind of like an infinite numbers of buyers and sellers, then any one individual buyer or seller in the market is like it's just such a minuscule component of the market that one individual person's behavior has no impact on the market, because at the extreme we've just got like gobs and gobs and gobs and gobs of people participating, and so each one person has a very, very next to nothing impact on the market, and at the extreme, if you can kind of push it to infinity, they don't have any impact on the market. Okay, if that is true, that at the extreme everyone is so small relative to the whole, then what that's going to mean is that any one buyer or seller's behavior is not going to be able to influence the price that's on the market. So because of this, everyone is just going to be a price taker. Okay, what is a price taker? A price taker means the market determines the price, and then if you decide to engage in the market as either a buyer or a seller, you're just going to take that price. So you cannot feasibly change your behavior in a way that your behavioral change is going to influence the price that's on the market, because you're just so small and insignificant at the extreme that no matter what you do, your behavior is not going to impact the market price. And so whatever the market price is, you just take it. Like, you cannot impact it. Okay, the third thing that's going to define perfectly competitive markets is free entry and exit. Okay, what does this mean? This means that people who would like to participate in the market, as a seller, for example, are free to open up shop and start selling the product and be a supplier. Similarly, existing suppliers are free to exit the market. Like, they can just decide we don't want to sell our product anymore. And they can do this very fluidly. So there's going to be zero barriers to entry. If you want to enter and start selling this product, join the club. If you're tired of selling the product and you want to leave this market, fine, like, see your way out. And so this is going to be important, as I'm going to show you, that firms are just free to come and go from the market in a very kind of fluid way. And then the third thing is that in perfectly competitive markets, the products that are being exchanged in that market are going to be identical. So the buyers and the sellers are trading identical products. Okay, what is an identical product? An identical product means that if shop A is selling widgets and shop B is selling widgets, then the widgets that are sold between shop A and B have to be exactly the same. So again, because we're thinking about like the far end of the spectrum, it's kind of hard to come up with examples like this, but one example of a market that's kind of has identical products would be like the market for concrete. So it doesn't matter if concrete company ABC is selling concrete, or concrete company Fine Roads is selling concrete. Like, concrete is concrete. So the idea is, if you want to enter the concrete market, you're going to be selling a product that's identical to your competitors. Another kind of example of a market where they trade identical products is agricultural markets. If you come from a farm family, you know this isn't quite right, but the idea is like, wheat is wheat. So it doesn't matter if farmer A sells the wheat or farmer B sells the wheat. Like, you're basically offering on the market products that are identical to your competitors. And then at the extreme, they're like perfectly identical. So again, we're thinking about kind of pushing this to the limit. And at the limit, everyone's trading products that are absolutely identical to everyone else. Okay, note that if everyone's trading identical products and everyone is a price taker, this kind of leads to something. So I'm going to just write this down here as note. So note, if everyone is a price taker of this identical product, then the quantity a person supplies or demands has no impact on the price. Okay, I'm kind of repeating myself here, but I want to drive home this point. So again, the idea of price taker is everyone's like tiny relative to the whole. So it doesn't matter what quantity a buyer wants to buy. It doesn't matter what quantity a seller wants to sell. Any kind of like quantity supplied or quantity demanded for an individual person is not going to impact the market price, because everyone's just a price taker. Okay, so let's think about how this would kind of impact things in terms of revenue. Okay, so I'm going to give you a little example here in numbers. So suppose we have some various prices. So let's just say that the price for concrete is $6. So 1 unit of concrete is $6. If we're in a perfectly competitive market, then everyone takes this price. It doesn't matter kind of how many units you supply. It doesn't matter how many units you buy. This is going to be the rigid price in the market that no one's going to be able to budge with their own behavior. Okay, that means that if the quantity that I, as a concrete manufacturer, sell is 1 unit, the market price is going to be 6. If I sell 2 units, market price is still going to be 6. If I sell 3 units, same thing. If I sell 4 units, same thing. So this is what price taking looks like. It looks like I can pick the quantity I want to sell. It's not going to influence the market price. Okay, if that's true, then let's think about the total revenue for a firm. So total revenue is price times quantity. So if I am a concrete manufacturer and I'm taking the price of $6, then if I sell 1 unit, my total revenue is going to be 6. If I sell 2 units, my total revenue is going to be 12. If I sell 3 units, my total revenue is going to be 18. If I sell 4 units, my total revenue is going to be 24. Okay, what about average revenue? So average revenue is going to be equal to total revenue divided by quantity. So average revenue is kind of like the idea that a firm brings in all of its revenue, that's a total, and then they want to figure out like what is the average amount I'm getting per 1 unit. So they divide it by the quantity that they supply. So to calculate average revenue, you would take total revenue, you divide it by quantity. So you take 6 divided by 1, you get 6. You take total revenue of 12 divided by 2, you get 6. 18 divided by 3, 6. 24 divided by 4 is 6. So this should be very intuitive. The idea is if they can't budge the price and their total revenue is directly linked to the number of units they sell, then the average revenue for each 1 unit that they sell is just equal to the fixed price that they get for that unit that they sell. Okay, what about marginal revenue? Okay, we haven't defined marginal revenue yet. Marginal is what we've explained before. So marginal is kind of like an incremental change, this time in revenue. So what we're going to say is that marginal revenue is equal to the change in total revenue divided by the change in the quantity. So this means if a firm ups their quantity by a little bit, so they change their quantity, what is the residual incremental change in total revenue? Well, to calculate this, let's think about what would happen if the firm went from selling 1 unit to 2 units. If they went from selling 1 unit to 2 units, then the change in quantity is 1, that's the denominator. But then the revenue went up from 6 to 12, so this is the change in total revenue. So the numerator would be 6, the denominator would be 1, so that gives you a ratio of 6. And since we're going from 1 to 2, let's put this down here in the 2 spot, second row. Okay, what now if the firm goes from selling 2 units to 3 units? Well, if your quantity changes from 2 to 3, that's been a delta Q of 1. You've changed your output by 1. And then the numerator is the change in total revenue. So if you go from selling 2 to 3, your revenue changes from 12 to 18. This is a $6 change in total revenue divided by a 1 unit change in quantity. This gives you a marginal revenue of 6. What if we fill out the table by going to the last row? If a firm is selling 3 and starts selling 4, change in quantity of 1, their total revenue is going to move from 18 to 24. That's a change in total revenue of 6. And this is what we've got. Okay, the reason I'm kind of discussing this in length is because unique to perfectly competitive markets is the fact that in perfectly competitive markets, the price is always exactly equal to the average revenue is exactly equal to the marginal revenue. Normally it doesn't work this way, so don't think that this is some kind of like generic result. This is very much unique to perfect competition. So we need to like peg this to perfect competition and say this is a unique characteristic of it. So therefore, in perfectly competitive markets, the average revenue equals the price. Average revenue equals the price. And the marginal revenue equals the price. Marginal revenue equals the price. Okay, so what's the next thing to think about? The next thing to think about is, okay, suppose you're a concrete manufacturer. So you are a supplier, you're a firm that does business in a perfectly competitive market. What is the goal of a firm in a perfectly competitive market? The goal is not going to be to increase your total revenue. If that was the goal and prices were fixed, then if you wanted to increase your total revenue, you just like crank out as much concrete as you can. But a firm's not just concerned about total revenue, they're concerned about profits. Profits are total revenue minus the cost that you have to pay to produce the good. So the firm that exists in a perfectly competitive market is going to have the goal of maximizing their profit. So this is like the goal of perfectly competitive firms. Okay, so I'm going to frame this in terms of a question. So the question is, what is the goal of a firm in a perfectly competitive market? The goal is to maximize profit. So again, often in economics, we abbreviate profit with pi. So if you need to in your notes, put a little parentheses next to this that says profit, but pi stands for profit. Okay, so let's think about how would a firm do this? So you've got this concrete manufacturer. They don't just care about revenue, they care about profitability. And perfectly competitive markets are kind of weird because each player in the game is so itty-bitty in comparison to the whole that they can't really influence much of anything in the market. And so we want to think about, what does a firm need to do so that they can maximize their profit? Well, let's think about kind of what are the strategies they could have. They could never do anything that would impact the price, so they're not going to try to like pick a particular price. But the one thing that they can play with is kind of their level of production. So what they need to do is they need to pick a particular quantity of concrete to produce that would maximize their profit. So how would they do that? So let's think about how you calculate profit. So profit equals total revenue minus total cost. And let's kind of think about this now. So they want to maximize their profit. Suppose you had a graph that plotted profit against total, or against output. So this is like the number of units of output they're cranking out. And the idea is they need to pick a particular quantity on here so that the quantity of production that they pick is going to maximize their profit. Well, let's suppose that the profit function looks something like this. So the idea here is profit is a function of quantity. So how profitable you are depends on how many units you choose to produce. Well, if this is the case, if this is kind of the relationship between profit and quantity, and they're trying to pick the quantity that maximizes their profit, then in this picture, the maximum profit is up here. So this is kind of as high as they get in profit. So ideally what the firm needs to do is they need to kind of try to make exactly this many units. Because if they make more units, then their profit will fall. If they make less units, their profit would fall. And so they need to make Q star number of units. And the question we're going to be grappling with today is like, how do they figure out what Q star is? Like, they know that they need to like crank out this many units if they're going to have the max profit. How do they do that? Okay, so this is where math becomes very handy. In calculus, you learned about derivatives, and a derivative is effectively a slope. So let's think about what is true about the profit function at this optimal quantity. Well, at this optimal quantity that they're trying to get to, the slope up here, the profit function, is 0. So if the slope is 0 at the sweet spot they want to be at, then what the firm could do is they could calculate the derivative of the profit function, because a derivative is equal to a slope, they could set that derivative equal to 0, and when they do that, they would be able to deduce what the optimal quantity would be. Okay, so let me kind of step you through this. Okay, so profit, I'm going to write this out just a little bit more longhand, is total revenue minus total cost. Total revenue is price times quantity. So what that means is that total revenue is a function of quantity. So how much revenue you have depends on how much you produce, your quantity. So in longhand, we can say total revenue is a function of quantity. Okay, just notation-wise, think about kind of old high school days. A function looks like something with a parentheses and then something inside the parentheses. The things inside the parentheses are the variables that affect the thing on the outside. So this is just another way of saying quantity is a variable that affects total revenue. Okay, total cost is also a function of quantity. So this is a function. So this is just saying quantity is a variable that influences total cost. Okay, so what we're going to do is we're going to take the derivative of this with respect to quantity, because quantity is the variable we're trying to solve the optimal value of. Once we take the derivative of that with respect to quantity, that's going to tell us all the slopes. And then we're going to set it equal to 0 because we want to set the slope equal to 0 and figure out where the specific quantity is that optimizes, maximizes profit. So we're going to take the derivative with respect to quantity, set that equal to 0, and that will yield the specific quantity that maximizes profit. Okay, so let's just do this. All right, so if you take the derivative of profit with respect to quantity, then the shorthand way of writing this is the derivative of total revenue with respect to, the derivative of profit with respect to total revenue. The first ingredient in this function is total revenue, which is a function of quantity. So this would, so the derivative, when we take the derivative, this would just be equal to total revenue prime. So just note that this is equivalent to kind of the change in total revenue divided by the change in the quantity. So derivatives, you're just saying an incremental change in quantity, how does it affect, in this case, profit? So for the first term here, you're going to calculate an incremental change in quantity. How does that affect total revenue? You're just going to abbreviate that as total revenue prime. Okay, the second term, if you take the derivative, is going to be total cost prime. That's equivalent to kind of the change in total cost divided by the change, triangle, in quantity. These two things should look familiar. This is marginal revenue. This is marginal cost. Okay, so this is equal to marginal revenue minus marginal cost. So what we've done so far is we've taken the derivative with respect to quantity. Now we need to set that equal to 0. So let's set this equal to 0. If we do that, then what we get is that marginal revenue equals marginal cost. Okay, this is incredibly important. Okay, what does this tell us? This tells us that if we're a firm in a perfectly competitive market and we want to maximize our profit, what do we need to do? We need to pick the quantity where marginal revenue is exactly equal to marginal cost. If we get these two things to line up, then what's going to be the case? We're going to be sitting at the quantity that maximizes our profit. Okay, so now we're going to kind of pull from our recollection of previous chapters and think about kind of how we would go about doing this. Okay, recall from our discussion of costs. Let's see if I can find a marker that works a little bit better. So recall marginal cost, one of the things here, has a curve that typically slopes upward. So we talked about this before. So this was kind of like the story of the bowl of water. You had a tablespoon that was your marginal contribution. So marginal cost curves, marginal cost curves are typically upward sloping. And then also recall something we learned today. What we learned today is that everyone in a perfectly competitive market is a price taker. So if everyone is a price taker, then that means if you plot price against quantity and everyone just takes the price, then it doesn't matter how many Qs they're choosing, the price doesn't budge because they take it. So that means the price line would just be just a horizontal line. So recall, everyone is a price taker. The price will be a horizontal line. And something else you need to recall, and we said in perfectly competitive markets, the price equals the marginal revenue. So this is the table that we had. We said all the numbers in the marginal revenue column are equal to the numbers in the price column. So now we've got a whole bunch of components to work with to kind of satisfy this. So we know marginal cost is going to slope upward. We know that the price bar is going to be a horizontal line, and we know the price and the marginal revenue are the same thing. So now we've got marginal revenue, we've got price for marginal costs. Let's overlay them in the same graph, figure out where marginal revenue and marginal cost curves intersect. Wherever they intersect, that's going to be where marginal revenue equals to marginal costs. At that crosshairs, there's going to be a corresponding quantity. That's the quantity that the firm needs to aim for in order to maximize their profits. Okay, so let's draw it all together. Okay, so if you have a graph, I'm going to label the vertical axis price, but effectively it's just a monetary amount, and the horizontal axis is quantity, then when you put it all together, you're going to have a marginal cost curve that typically slopes upward. Sometimes there's a little tail here, sometimes it has a different shape, but typically it looks like this. We know everyone's a price taker, so price is not going to budge no matter what the quantity is. And we know that the marginal revenue is equal to the price. So now, we know that if a firm wants to maximize their profit, what they need to do is they need to pick the right number of units that they're going to produce. The right number of units to produce to maximize profit is the number of units where marginal revenue equals marginal costs. Marginal revenue equals marginal costs at this crosshair. This corresponds to a particular quantity. This is the quantity that the firm needs to produce if they want to maximize their profit. Okay, so this is quantity or production level that maximizes profit. Okay, so far, theoretically, everything's kind of like easy peasy. But let's think about what if we've got a firm and he's not doing this. Okay, so let's suppose that a firm, instead of producing the right number of units that maximizes profit, maybe he's producing this quantity Q1. Okay, he needs to be ramping up his production, right? So if a firm is producing Q1, then when he looks in his books, what he should see is that the price that he's selling his goods at is less than the marginal cost. So if price is, or sorry, the price is more than the marginal cost, the price is more than the marginal cost, then what he needs to do is he needs to ramp up production because he's underneath the optimal amount. Okay, so let me write this out. So if a firm is producing where the price is greater than the marginal cost, which is another way of saying the marginal revenue is greater than the marginal cost, then he needs to increase his production because he needs to get up to Q star. Alternatively, if a firm is producing somewhere over here, Q2, so here he's like overshot. Now he's producing more than what he needs to. So he's like cranking out too much concrete relative to what's optimal. If this characterizes his behavior, then when he looks in his books, what he should see is that the marginal cost is exceeding the price that he's selling his good for. If he looks in his books and realizes that there's this disparity between the marginal cost and the price, then a red flag should go up to him, and he needs to know he needs to like rein in his production a little bit to get down to Q star. So if a firm is producing where the price is less than the marginal cost, or in other words, the marginal revenue is less than the marginal cost, then he needs to lower his production. Because recall, what he needs to do is he needs to have marginal revenue exactly equal to marginal cost. So here they're not equal to each other, here they're not equal to each other. Either he needs to ramp up production if this is going on, or he needs to slow down production and kind of take it easy if this is going on. And then once he gets to the spot where the marginal revenue equals marginal cost, he's good. Like he's getting as much profit as he can feasibly get. Okay, so what we need to think about next is Q star is like the number of units that a firm should produce if they're going to get as much profit as they feasibly can. But it doesn't tell us like how much profit they're getting. So maybe it's the case that the optimal Q is like 50,000 units, and if you produce 50,000 units, then you get as much profitability as you possibly can. But that doesn't tell us if what is as good as the firm can do is them making a profit of $1 million. Is that as good as they can do? Or is as good as they can do making a profit of 2 million or 3 million? So we found the quantity that like gets us to the top of the profit hill, but it doesn't tell us like how much profit they're actually making. We just found out like what is the quantity that would get you to the top, but it doesn't tell you like how high is the top. Okay, so now we write. Okay, so but I'll start with that. Although Q star, so again, this is this quantity that we've been trying to solve for, get to, tells us optimal production that will get a firm the most profit they can feasibly get. It doesn't tell us how much profit they're actually making. Okay, so here's where I'm going to show you how to calculate that. So it doesn't tell us how much profit they're actually making. Okay, so let's calculate how much profit a firm would actually make if they produce at a particular quantity, specifically if they produce at the quantity that optimizes their profit. Okay, so I'll write some more words. So to figure out amount of profit, what do we do? Well, we know that profit, again, is equal to total revenue minus total cost. And let's just kind of decompose this a little bit. So total revenue is equivalent to price times quantity. And here we're going to do a little bit of a math trick just to show you something. So another way you can express total cost is average total cost times quantity. Okay, why is that the case? The reason it's the case is because average total cost equals total cost divided by quantity. So if you just take this quantity, you move it over, you get average total cost times quantity equals total cost. We got total cost here. Let's just replace total cost with average total cost times quantity. There's a reason for this. Okay, so we've just kind of rewritten the profit equation. The reason we're writing it specifically like this is because both of these terms have a Q in it. So let's just like pull out the Q and then take all the leftovers and put them in a parentheses. So another way we can express this whole thing is we can have price minus average total cost times quantity. So this is another way of expressing profit. Okay, the reason we're writing it this way is because if we can know the price in the market, so if we're in a perfectly competitive firm, then everyone's going to take the same price. And if we can know the average total cost of a firm, we can subtract these two. We can multiply it by the quantity that the firm is choosing to produce, and that will tell us how much profit they're making. Okay, just kind of note the sign of the profit. So so presumably, first of all, a firm is always going to produce a positive quantity. Like they're never going to produce negative 2 units. Either they're going to produce 0 or 1 or 2 or 3 or some positive number. So this is going to be positive. If the firm is taking a price that is above their own average total cost, then the price will be bigger than what is being subtracted out of it, and this whole thing will be positive. You take a positive times a positive, that means their profit will be positive. If, however, the price they take on the market is less than their average total cost when they produce the good, then they're going to take a tiny price, subtract from it a bigger number. The term in the parentheses is going to be negative. When you take a negative times a positive, you're going to find that they're making actually negative profit. Okay, so what's really important here is the size of the price relative to the size of the average total cost. So this is super, super important. So to determine profitability, or the amount of profit a firm is making, it's going to be super important to compare price to average total cost. Okay, let me keep this equation, erase the rest, and then draw some pictures. Okay, so remember, this is the equation for total profit. So if we can find these 3 variables on a graph, we've got all the components we need to actually calculate total profit. Okay, the pictures I'm going to be drawing now are pretty precise, so make sure you're following around and kind of drawing them similarly on your own page. Okay, let's just say this is case 1. We're going to plot against each other price and quantity. And let's suppose a firm's a price taker, so they're going to have a price that doesn't change based on the quantity. So let's just say that this is the price in the market. We know that the price is equal to the marginal revenue. We know that marginal costs generally slope up, so let's draw a marginal cost curve. And what we also know, the idea of the bowl of water in the teaspoon, is that average total cost, the bowl of the water, is U-shaped. The bottom of the U is where the marginal cost curve intersects the average total cost curve. And so let's incorporate that into this picture. And then what you need to do specifically on your paper is when you draw this, make sure that the bottom of the U in case 1 is underneath the price bar. So what we've got here is we've got average total cost as a U. The marginal cost curve intersects it at the bottom of the U. And then we've got the price, which people take. They don't affect the price. So no matter how many units they manufacture, price doesn't change. And it's equal to the marginal revenue. Okay, here's where we're in business. Okay, take a deep breath. We're going to tie it all together, tie the first half of this together. So you got a concrete manufacturer. He wants to pick the number of units of concrete to make that'll maximize his profit. What does he need to do? He needs to pick the quantity where marginal revenue equals marginal cost. So we had over here this little note. We said if he wants to pick the right quantity, if he wants to produce the right quantity, if he wants to produce the profit maximizing quantity, he needs to produce the quantity where this is satisfied. We can figure that out from the graph, right? So we have marginal revenue, we got marginal cost, so let's find where these two things intersect. That corresponds with a particular quantity. This is the quantity that the firm would need to produce if he wants to maximize his profit. The question remains, okay, this is kind of the sweet spot. If he produces this, he can't make any more profit than possible, but how much profit is he making? Well, we have an equation for that. So if this is the number of units he's producing, well, profit is equal to the price in the market minus the average total cost given his production level times his production level. Okay, we've got all of that up here. So he's producing right here. He's producing this number of units. The price is right there. At this level of production, Q, the average total cost is right there. Okay, so far so good, right? So we have a price minus the average total cost. That's positive. And then the quantity, well, that's right here. So note, if you calculate the profit, this is equivalent to the area of a rectangle because this is that distance. Quantity is this distance. So if you take a height here times a base here, you're going to just be calculating the area of a rectangle. So what that means is that the area of this rectangle is equal to the profit that the firm is making. Let me pick this apart one more time. First thing the firm does is they set marginal revenue equal to marginal cost. They figure out the optimal quantity. They then say, okay, I'm committing to producing Q star. This is going to maximize my profit. The second part is okay, well, what is my profit now that I maximized it? Well, the profit is going to be the difference between the price and the quantity. So he's committed to this. So at this quantity, here's the price, here's the average total cost. The difference between these two things is this amount. He multiplies that by the quantity. The quantity is this amount. When you multiply these two things, you're effectively calculating the area of a rectangle. The area of this rectangle is equal to his profit. It's going to be a specific number. So this area corresponds to a dollar amount. That dollar amount is his profit. Okay, note that in this case, he is making a positive profit. How do we know that? Because this first term here, price minus average total cost, is positive because in this particular setup, the price is bigger than the average total cost. Okay, and then again, you can calculate the specific amount of positive profit. Okay, let's consider case number 2. And then, let's see how we're doing on time. And then we'll break. Okay, case number 2 is, let's plot price against quantity. And let's say that in this perfectly competitive market, everyone takes the price. Here's the price. It doesn't matter how many units you produce. The price is, you can't change the price. Price is equal to marginal revenue. Again, marginal cost curves normally slope up. And then the average total cost curve, which is a U, has to intersect the marginal cost curve at the bottom of the U. But the way we're going to draw it this time is let's let the bottom of the U hit the marginal cost curve somewhere north of the price bar. Okay, so again, components that need to be characteristic of your own graph. You've got a price bar that's horizontal line that's equal to marginal revenue. You've got a marginal cost curve that slopes up. You got an average total cost curve that's U-shaped, where the bottom of the U is where it hits the marginal cost curve. And now in case number 2, the bottom of the U is above the price bar. Okay, let's think about this concrete manufacturer. So first thing, he needs to ask himself, how much concrete should I crank out to maximize my profit? Well, I need to crank out a Q where marginal revenue equals marginal cost. Here's my factory. In my factory, here's the marginal revenue, here's the marginal cost. They intersect right here. This is the amount of concrete that I need to produce if I'm going to be as profitable as I feasibly can be. How much profit am I making now? So to calculate the profit, you would say, okay, the firm commits to making this quantity, because this is the quantity that kind of like gives him as much money as he can possibly get. At this quantity, here's the price. At this quantity, here's the average total cost. And again, here's the quantity. So we've got the price, we've got the average total cost, we've got the quantity. Okay, in this situation, the concrete manufacturer isn't in great shape. The reason he's not in great shape is because the first term here is price minus average total cost. If you take price, which is kind of small, and subtract from the average total cost, which is bigger than it, then this is going to be negative. So this is going to be like the amount of money on average he loses per unit of concrete that he makes. So price minus average total cost is going to be this vertical distance, but negative. Quantity is, again, this horizontal distance. So now, when you take this product, so parentheses times Q, what you get is equivalent to the area of this rectangle, but it's going to be a negative amount. And the reason it's negative is because average total cost, or price minus average total cost, is a negative number multiplied by a positive number. So this is going to be equal to the amount of money he's losing, or his profit, which is going to be negative. Okay, so in this situation, there's negative profit, and this is as best as the firm can do, because when you do the calculus, this is the optimal quantity that would maximize his profit. But in his particular setup, the best he can do is still losing money. So he could definitely lose more money, but the best case scenario is he's still making a negative profit. And specifically, the amount of the negative profit is equivalent to the area of this rectangle, but it's going to be whatever that number is. That's how much money he's losing in profitability. So that's going to be like his amount of negative profit. Okay, so I'm going to break here. For next class, what we're going to do is we're going to say, okay, well, where does a firm go from here? So if a firm is losing money, what's going to happen? If a firm is making money, what's going to happen? But what's important for you to know today is, one, how to find the quantity that maximizes profit. How do you find that quantity? You find our marginal revenue is equal to marginal cost. Second important thing is, at that quantity, what amount of profit is the firm making? This is, at this quantity, he's going to do as good as he can in terms of profitability, but how good is as good as he can do? And you can calculate that by anchoring yourself at his quantity, comparing the price and the average total cost at that quantity. Whichever, depending on which one's bigger, that's going to tell you whether his profit is positive or negative. You're going to take that disparity between the price and the average total cost, multiply it by the quantity, and that's going to either tell you how much positive profit he has or how much negative profit he has. Okay, so this is super confusing. Well, let me know for sure so I can try to help if this is making sense, or if you just have like clarifying questions, let me know in the next few minutes, and then after that we'll meet back and do an exercise. the exercise, I've got 2 questions, each have 2 parts. So for question 1, I have a picture for you to look at. So this picture has a price bar, a marginal cost curve, an average total cost curve, and in the picture that will appear on the screen and that will be in Blackboard, there's going to be coordinates, so you'll know like 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, and there'll be a grid on here. Okay, so the first part for question 1 is I want you to tell me what is a profit maximizing quantity. So based on the picture that I give you, tell me the Q that would maximize the firm's profit. So it needs to be a specific number structured as profit maximizing quantity be Q equals 5 or 7 or whatever the number is. Okay, part B is at that quantity, what is the profit? So calculate a number which is going to be consistent with the area of a rectangle, and that number is going to represent how much profit the firm would be making at their profit maximizing quantity. Okay, question 2 is exactly the same thing, but there's going to be a new picture. So for question 2, you got a price bar that's lower. You got an upward sloping marginal cost curve, a U-shaped average total cost curve, and what I want you to do based on the new picture is to tell me what is the profit maximizing quantity, so what Q should the firm produce if they want to make as much profit as possible, and then B, how much profit are they making when they actually manufacture that number of units. For A, you need to tell me a specific number for Q. For B, you need to tell me a specific dollar amount for both questions 1 and 2. And once you're done with that, you'll be good to go for the day, and we'll finish up the chapter next time I see you.